Hi everybody. One of the things we'll be using a lot of in JavaScript are numbers. And depending on the kind of application you're building, whether it's basic or complex, there's a very good chance there will be a number playing an important role somewhere in your code. And so in this video, we're going to look at some of the basic cases of numbers and how to use them, and also look at some of the more interesting, more bizarre, yet also important cases as well. So let's get started. To make this video more easily adjustable and far less boring than it probably already is, we'll be jumping between code and slides to kind of break up the monotony of just looking at numbers and so on. And so to start off with, I'm not going to be using a code editor for this particular video. Instead, I'm going to be using the JavaScript console that the browser provides. You can use a code editor if you want. There's no right or wrong here. So feel free to use whatever makes the most sense for you. Now, the thing about numbers in JavaScript is that you can use them directly. You know, like everything else in JavaScript, there's really not much pretense or guardrails or handholding that you need to kind of plan ahead for in order to use them. So for example, I can just do let stooges equals 3, and then you can see that the value of 3 is now assigned to my variable stooges. So if I were to check the value for stooges, you can see that number 3 gets defined. And so that's a very easy, direct way of representing a number. And the numbers you specify aren't really designed to be integers or decimals or small numbers or large numbers. JavaScript doesn't really care. You can just use any set of number very quickly without having to explicitly define what kind of number that you want as well. So for example, if I use a decimal, like let pi equals 3.14159, I can just do that directly. And now you can see that the value of pi is 3.14159. I can easily just jump from having to go from decimals to even hexadecimal values. So that color equals, 0xFF. The way you can tell that is the hexadecimal value is the existence of 0x here. We'll cover hex values in greater detail much later, so don't worry about it too now. But just know that I just was able to define a variable called color. It could have been anything, could have been some text, could have been a pointer to an element on the DOM, or it could have been, in this case, just a hex value, 0xFF. And of course, I'm also not limited to being able to just have small numbers. I can also go really large with exponents. In this case, the value for the mass of Earth is 5.97 times 10 to the power of 24. And if I were to try to replay this back, you can see that's the value that is currently displayed. And so if you've been familiar with numbers in other languages, especially strongly typed languages, you might find this a little surprising. There's no concept of anything that has to be specifically defined as a float or an integer or something like that. There is, or there are certain types in JavaScript. There is big int, for example, that we'll cover later on, where it does deal with like numbers in a certain detail. But for 90%, maybe 99% of your everyday use case of numbers, you can just use them directly like you would any value as part of anything that you do. So the thing about numbers is that not only can you specify numbers, you can also do simple calculations with them. The basic operators like addition, subtraction, multiplication, division, they're all there. So I can do like let total equals, for example, 4 plus 26, and the value that gets stored for total would be 30. As you can imagine, I can do let average equals, for example, total divided by 2, and you can see that the average value would be 15. Two numbers divided by 2, in this case, the average would be 15 for this value. And I can also go even more interesting. I can do let double pi equals 2 times 3.14159, and then you can see that the double of pi is displayed here as well. And so you can do remainders, you can do subtraction, you can do all those things. So subtraction would be, let's say, instead of actually typing in a variable, so my 50 minus 25, for 25. I can also do let remainder equals total, let's say if it's divisible by 7, for example, the total of 30 that we had earlier, I can do that, and then you can see that the value of remainder is 2, because 4 times 10 is 28, and the remainder is 2. And then you can keep doing a lot more things like this, but think of the basic calculator commands that you have in a very basic calculator. They will just work directly and as expected in JavaScript as well, which is kind of nice. Now, the one detail to keep in mind is, and this might be something you're probably very familiar with from having either taken this class when you were much younger or having recalled it from something you might have done recently, is there is an order in which things are evaluated. And this order is, again, directly related to what it would be in arithmetic in the real world. The order is first parentheses, then exponents, then multiplication, then division, then addition, then subtraction. You know, it's commonly referred to as PEMDAS, but if that's hard to remember, you can also use a mnemonic device. Please excuse my dear Aunt Sally. You can replace the names with something that makes more sense. For example, I do not have an aunt named Sally, but you can, so if you don't have an aunt named Sally as well, replace it with anyone else whose name happens to start with S. It doesn't have to be too complex in that case. So to see an example of this, for example, I can do let bar equals, let's do 5 plus 2 multiplied by 3. Now, using the example from earlier, like PEMDAS, we know parentheses is the first part of it. So parentheses will get evaluated first. So it'll be 7. And then multiplication happens later because there's no exponents here. So it'll be 7 times 3, which will be 21. Let's make sure I'm right here. Yep, it is 21. And so if you're doing long calculations, just be sure to keep this in mind to make sure the value you're getting is the one you're actually expecting. And now we get into some territory you might have seen a little bit of earlier when we looked at loops, but also in terms of just the various operators you have to make very common things easier. So for example, if you want to increment a value by 1 or decrement a value by 1, you have the plus and minus minus. If you want to increment a value by an arbitrary number or decrease a value by an arbitrary number, you have plus equals, minus equals. If you want to multiply the value by itself, you have the multiplication equals, and then if you want to divide it, the opposite of that, divided by itself, you have I, and then you have the division equals. And similarly, to find the remainder once the division has already happened, you can do the percentage sign equals, and likewise, if you want to do an exponential operator where I is raised to the power of n, you can do I star star equals, and this will give you a lot of these values. Now, I'm not going to spend too much time on this particular example, so you probably have seen too much of this already. So for example, I can do let I equals 4. If you do I plus plus, you'll see that it's still going to be just 4. But if I do check out the value of I, you'll see that 5 is what gets returned. So when you do that incrementing or decrementing, the immediate return value is the value it was before the actual operation takes place. But then afterwards, though, the value is going to be the result of that. And if I want to do let me do a decrement for I, you'll see 5 as the initial value. If I go to I, it becomes 4. And you'll see this with for loops quite a bit, where we're going to do a lot more of work in this space. Now, there are some quirks here to keep in mind. So for example, you can do let I equals 4 again, and then I can do let j equals I plus plus. Now, this is an example where what I talked about earlier, j is going to be 4, because like we expected. But what if I did something else? What if I did let I equals 4 again, just reset the value. Actually, let me clear this out so I have room. Let I equals 4. Let I equals 4. And instead of having the value of j be I plus plus, what if we do plus plus I? What do you think the output of this is going to be right here? Well, in this case, the value of j is going to be 5 as opposed to 4, because when you do plus plus, in the beginning, the value that gets stored is actually the total result of, the value gets returned is the value of the stored value as opposed to that. So regardless, what it means is that the position of the operator really determines whether the incremented value will be returned or the pre-incremented value will be returned. Just something to keep in mind. Now, in terms of if I had to rate how boring that little factoid was compared to everything else we'll see here, it's going to be a 5 out of 10. So just brace yourself for more things that happen to go on here. So next up are hex values and octal values. So we kind of already saw that, to use a hex value, you can just go ahead and use the 0x prefix and then the number that you want. So in this case, I have leap equals 1337. See how clever of me there. But then if I want to use an octal values are essentially just going to be values where I can just use the 0 as the prefix and then 2471. So any number you start with a 0 will automatically be inferred to be an octal value. And let's see if I were to check that value again, you'll see that the octal form of 1337 is 2471 with the 0 as the prefix to make this all happen. Now, as just a quick aside, there will be cases where you need to go from a hex value or an octal value into an actual numerical value instead. So there would be a string that needs to be parsed into, needs to be a number. And so the way you can do that is you can do hex value equals, there's a built-in function called parseInt, and that I can put for example, FFFF, which is all white, and then say it's going to be in base 16. And then now I have my hex value, which is now the full value for that. And similarly, I can also do the same thing for my octal case, where I have my octal value variable, and I can do parse int, and I can do 0, 1, 1, and then make sure to specify the base of 8, which clearly indicates that it's an octal value. And then if I were to see the value of that, I can see that it is 9. So just keep that in mind in terms of like parsing numbers or parsing some data from a JSON object, which we'll cover later on. You'll be using this particular function quite a bit. Now, next, there also are two special cases. There is the number for infinity, which you can just go ahead and do let infinity, if I spell it correctly, equals just infinity. It says capital infinity, and that's pretty much it. So if you ever need to use infinity in calculations, you can just go ahead and do that. And of course, infinity times 2 doesn't really make sense because infinity is infinity, and that's the value that gets stored. And sometimes you might be dealing with a number that is not really a number at all. And so, for example, I can do like 1920 divided by blah. This doesn't really make sense, right? I'm dividing a number with something that is clearly a text, clearly string. It's not even a variable, it's a string. And you'll see that nope equals undefined, but it's what gets returned. And you can see the value for nope equals NaN, which really stands for not a number. So those are really the basic numerical operations that you should be aware of, that you'll run into without having to go into a whole level of like detail or any specialization that comes in. For the specialization, for the special things that happen, that's where we have the math object and a lot of things inside of it. So the first thing the math object provides is a bunch of constants that you might need for the type of calculations you might want. You have the Euler's constant, you have all the various logarithmic values, the natural logarithm of 2 and 10, the base 2 logarithm of e, the base 10. You also have math.pi, which goes into much greater levels of precision than just the 4 or 5 that we saw in the example so far. And because the square root of 1/2 and square root of 2 are so common, you have math.square on 1 underscore 2 and math.square 2 available as those right there. I don't know how you pronounce it. Is it squirt, or do you just spell all the acronyms out SQRT? I don't know. I'm sure someone will correct me at some point in the near future. Now, next part is rounding numbers. You will be rounding numbers all the time because JavaScript, like a lot of programming languages, tends to like to go into either too much detail or just have unnecessary detail that would be just kind of, I wouldn't say damaging to your code, but would just cause errors that you might not be wanting. So you have math.round, which rounds a number to the nearest integer. And this is kind of like what you might have learned in rounding in general, is basically if you have a number that is greater or equal to 0.5, you will go to the next integer on top, that's one greater than what you have right now. But if the number you're trying to round is less than 0.5, you'll go down, or you'll stay at the number you currently are in. And then math.ceil and math.floor kind of go into a little bit level of detail, where ceil goes into the number that is greater than whatever the decimal value you have right now, and it's an integer. And then floor goes to something that's less than or equal to the number you have currently. And these are worth kind of checking out as well. So let's say that I want to do math.round, and the number I want to put in is like 3.14159. And if I were to see that, you can see math.round gives me the value of 3 because 3.1 is less than, the 0.1 after the decimal is less than 0.5. So if I were to do math.ceiling of 3.14159, you'll see in this case, because it doesn't matter, any point after decimal will always go to the next integer. So it goes to the integer 4, which is 1 greater than 3. And then of course math.floor, it always just keeps you at the current number they need to be in. So you used to stay at 3. So you just imagine ignoring all of these things. Now there is one detail I want to call out as well. If you want to round to a precise number of digits, so instead of going to the nearest integer, there is a number.toFixed method where you can specify the actual number of digits of precision that you want. And so for example, I can do number.toFixed. The number I need to put is actually 3.14159.toFixed, and then I can specify the number of digits I want. And so you can see if I put 2, you can see that 3.14 is going to get returned. If I do 3, it goes 3.142. And if I do, let's say, 4 digits, you'll say 3.1416, which is basically, it rounds, it's a rounding function. So you can see that when the 4 digits is 5, but then one after that's a 9, which is greater than what you'd expect from a 5. So it goes into 3.1416. So keep that in mind so that you have a way of easily rounding to precise degree of precision, which is often handy when it comes to like certain calculations, or currency is a common one, but currency is its own special thing, which we'll need to deal with differently. We won't talk about currency in this video. The next one are the trigonometric functions. This is going to be a lot of fun, especially when it comes to animation or doing some really interesting physics-like work. So you have all the common ones: cosine, sine, tangent, arc cosine, arc sine, arc tangent. You can just use them as the way it is defined here. You can pass in the value and it'll get you the number you want for it. And just to give you an idea of what this looks like, if I were to do angle equals math dot cosine, and you can, instead of doing something, let's say I do something like math dot pi times 2. If you know what the answer should be, it would probably be 6.12. Okay, a really, really small number. But, you have to go into radians. But this, you can figure this out. Like math dot cosine, sine, passing the angle, and the value will be returned for you. So next one are powers and square roots. So if you want to raise a number to a specified power, you have math dot pow. If you want to raise the Euler's constant to a specified number, you have math dot exp. And then the last one is math dot square root or squirt, where you can return a square root of a given, for a given argument. For the most part, math dot pow and math dot square root will be the ones you'll use the most, so I wouldn't spend too much time beyond it. The last two tidbits are math dot abs, which is the absolute value of a number, and math dot random, which returns a random number between 0 and less than 1. These are kind of cool, so it's worth looking at. Let me clear this one out. So I can do if I were to do math dot abs of, let's say, 30, it's just going to be 30 because it is the absolute value is that. But if we do math dot absolute value of minus 30, you'll see the value is 30 as well, because the absolute value, it doesn't really care about the sign. It doesn't care about if the number is in the negative space or the positive space. It just returns the value itself. And then math dot round is interesting, and we're going to have a separate video on this one specifically. Sorry, not round, random. Random returns a number between 0 and then a number just less than 1. So never quite 1, but just close to being 1. So you can keep trying this out. You can see that the number changes every time. So math dot random keeps returning, as you might expect, a random number, and it has a lot of degrees of precision, and it's one of my favorite functions to use in the whole number space, because so much of what we do visually, especially when it comes to more interactive things, have a degree of randomness to them. So it's kind of fun to have those be around. So we're nearing the tail end of this video, so I just want to make sure that we have a quick review of all the things we looked at. We first started off with entering numbers, which in the world of JavaScript is pretty direct, pretty straightforward. You just enter the numbers, it just works. We looked at the operators, all the basic calculator commands, addition, subtraction, division, multiplication. We looked at incrementing a value, decrementing a value, and then some other variations of it, like multiplying it by itself, dividing by itself, using the remainder, percentages, and all of that. We looked at hex and octal values, looked at infinity, we looked at NaN, not a number. We looked at all the math constants, the various ones from like Euler's number to pi to all that. We looked at rounding numbers, rounding up, rounding down, and just doing straight up rounding as normal. We looked at trigonometric functions, powers and square roots, absolute value, and random numbers. So that's a lot that we covered, but hopefully, it covers the basic things to the point where if you ever run into it, if you're in the code you're looking at, or if you ever need to use a specific number kind of capability, you have everything you need here to make sense of it. And the one thing for completeness I should also mention, there's also a number object. We primarily saw the math object, and we use the number object as part of rounding to a specific degree of precision. We use number.toFixed, for example. But the number object contains a whole host of things as well that might be pretty important to look at. But in reality, though, I've never had to go into it for anything beyond toFixed. In a future video, I may cover number. I'm not really sure, but I'll be very surprised if in real life, outside of number.toFixed, you need to know how all this works. So there you have it, a quick overview of both the very common cases of what numbers you might be using in JavaScript and some of the more or less common ones that you may not really use regularly, but when you need to use them, you'll be happy to know it exists. Like, how often do you tend to use like cosine, sine, and tangent outside of like visualization scenarios? Probably not very common, but when you do enter those scenarios though, you know how to use them right now. So with that, if you have any questions, please post in the forum at forum@KIRUPA.com, where I and others will be happy to help you very, very quickly. I don't recommend posting in the comments in YouTube or Twitter or Facebook because A, the formatting options aren't always great, and second, I don't often get to see them as frequently as I would comments posted on the larger KIRUPA.com community. So formatKIRUPA.com is the best place to get your questions answered. So if you like this, tell your friends and enemies all about numbers. I want to say mostly enemies, given how boring this video was. You don't want to lose friends over this particular video. Hit subscribe to be notified of new videos, new, more interesting videos, I would say. Follow me on Twitter and Facebook for more updates on number-related things, non-number-related things, and a whole lot of other web development topics. And if you found this information interesting, then this also exists in book form, both paperback and ebook edition in my new book, JavaScript Absolute Beginner's Guide. A lot of people seem to like it, at least the reviews seem to say so. I'm hoping you would like it as well. So check it out. And with that, I will see you all next time.